Hi, my name is Israel Bagashaw. I'm an application scientist here at LI-COR. Today I want to show you how to do a zero baseline and a span calibration on the LI-7800 series trace gas analyzers. Today we're using the LI-7810, so we'll do a zero calibration, baseline calibration, and a span calibration with methane. We will be using these two tanks. This is my zero gas or a baseline calibration gas. It is what they've called volatile organic compound free or VOC free tank. We use those because we've gotten reliable certificate of analysis from the supplier that they have very little or zero methane in them. Your typical zero air tanks may have some methane, a few ppbs of methane. But the VOC free typically has a lot less or almost no methane. So we're using it with a two-stage regulator. I've set it to slightly above ambient, and I've set the flow on the flow indicator to about 1 liter per minute. That's much more than the instrument needs, and I am using a bypass or excess flow setup. So the tank air is going into the leg of this teeth fitting here, and I'm pushing the gas into the analyzer is subsampling or sampling what it needs from this flow, and the excess is going out this coil tubing over here. So we suggest taking several, the zero or baseline calibration is going to take a while. So when you do this baseline calibration or span calibration, you want to make sure you have enough time and you don't rush through it, because the calibration is going to be applied for all the measurements that you take subsequently. So you want to do it carefully and use reliable standards, and make sure you're not using nitrogen or methane mixed in nitrogen or nitrogen balanced tanks. The instrument is designed to work in measurements of air, so you want to use methane in air or air balanced tanks for doing the calibration. So I've already started flowing the gas, as I said, at about near 1 liter a minute. The instrument takes about 0.3 liters per minute, and so the excess is flowing out. You can adjust that to about half a liter or 0.6 liters per minute. And we're looking at the software. We're connected here through the Ethernet cable, and we're monitoring the gas concentration. So for zero, if you look here on the software, you can see that the methane readings are relatively stabilized, as well as the CO2, but however the water readings are still falling, and this is why it's going to take a while for doing the zero. So you can click on each gas to see further detail. So you can see for the last 5 minutes the average value is here, and the slope is essentially zero for the last 5 minutes. So we need to look at water primarily. It's also trending down, but it's only trending down by a few ppm. This is in the noise of the instrument. So we're just gonna wait until everything is stable. Water looks getting to a stable state, methane looks to a stable state, so we can go ahead and go to the calibration. One thing I would mention here, so right now we're looking at a downward offset of about -5 ppb on methane. This is, it's not out of the norm to see that after several months of operation. But if you see from, within a few weeks or within a few days of several ppb offset or several ppm offset on CO2, it may be that there's something else going on. Is the plumbing correct? Is there some leak, or is the instrument operating at the right conditions? Do you have all the indicators green on the status page or on the settings advanced page? So you want to make sure it's not an impact of the setup or something else before we conclude it's calibration drift and try to calibrate it out. So when you're ready to calibrate, once the gas readings are stable, and when you're ready to calibrate, you go to the settings page and go to the advanced page. So one more additional detail. So if you see a huge calibration offset or a huge offset in the measured values, maybe the instrument is using incorrect calibration, or it's doing something it's not supposed to do. So you can use this factory reset option, or you can revert back to previous calibration. So you can choose from a list of calibrations and go back. So we're ready to calibrate this instrument, and we'll do the 0. That's the baseline calibration that we're doing. And when we click this button here, 0, what happens is the instrument is going to record the absorption spectrum with 0 gas flowing and take several minutes of reading and use an average spectrum as the baseline spectrum. So all future measurements will have that baseline spectrum subtracted from them. So you don't want to change any of the flow settings or the plumbing or the instrument settings when it is doing that averaging. So, and it's going to take about 4 to 5 minutes. So once you click 0, the instrument will stop outputting data to the screen, and it will just tell you to wait, and you don't want to change anything in that period. So we'll go ahead and click 0, and it's going to ask us to confirm, and yes. And we see this screen where it says please wait while the instrument is zeroing. So we'll give it about 5 minutes for it to complete the 0 process, and in the meantime, you can work on getting your span tank ready, getting the plumbing for that prepared. And so we don't expect the 0 drift on the instrument to be significant. Our specification says 1 ppb per 24-hour period. And it's we see that in the instruments that we produce. We do the testing here, and we see that in the instruments that we test after manufacturing and production, and all of them meet that specification. In fact, that specification doesn't mean 1 ppb per day for continuously or a cumulative spec. It's 1 ppb per day, but it doesn't add up. So over several days, we don't expect over 10 days 10 ppb. It hovers around 1 or 2 ppb over a month. So if that's a significant offset you want to correct for, you can do the 0. For span, we think the span is stable, and we don't expect more frequent calibrations, but if you have a very precise threshold for span, you can check that regularly and adjust as necessary. Now I'm using one more thing I will mention. I'm using plastic tubing to demonstrate this. If you're worried about small offset and small change in concentration, you want to avoid using plastic tubing and use metal tubing with compression fittings all around. So while the instrument is zeroing, we'll go ahead and get our span tank ready. So the 0 process is done, and it takes us to the stage, to the screen we were. You can see the last 0 is the date we did it today, and so we can go back to the home page and look at the readings. So now the methane reading is hovering around 0, the CO2 reading is also hovering around 0, and the water reading is also hovering around 0. So all of the readings are now reading, all of the gases are reading 0. So the 0 procedure that we do is for all 3 gases. And when we do span, it will primarily be for methane, and we'll go ahead and do the span now. Okay, so we're ready to go ahead and perform the span for the 7810. So this is a 7810, so it's a primary CH4 instrument. So all the spectroscopy is optimized for methane, and the water and CO2 follow what we do for methane. So when we do the calibration, we primarily calibrate the methane, and the same span adjustment that gets applied for methane will be applied for CO2 and water as well. So right now the readings on the instrument are from ambient room air, and our room air and our city today is reading twice what the global average is, about 1.9 ppm, but it's reading 3.9 ppm or 3,900 parts per billion. and some days we see that. So the calibration tank that I have is a near ambient, so when I go ahead and connect the tank, you will see the readings drop. I have it set up in similar fashion to how I had the zero gas. So we're using a two-stage regulator, where the second delivery gauge is set to higher than ambient pressure, and we're using a T-fitting with excess flow of about 1 liter per minute. So the instrument is sampling what it needs, about 0.3 liters per minute, and the rest is being exhausted. And we're using this connection, this T-fitting, this leg of the T, to avoid isotopic fractionation. And you can see on the screen that the methane readings are stabilizing, and the CO2 is also stabilizing, and the water is dropping quickly as well. So we'll give it a few minutes for the readings, especially water, to level out, and we'll go out and do the span. And we need to know the span value of the tank with good accuracy. So this instrument is a high precision, high accuracy instrument, so we don't want to use a low grade calibration tank that has significant uncertainty. If we are going to do the calibration, we need to have a tank that has good accuracy, and we can get a certificate of analysis, or a certificate that the supplier of this tank provides, that says the methane in air reading is about 2 ppm plus or minus some uncertainty. So this tank right here has 1.99 ppm with plus or minus 1% uncertainty, and the instrument is reading right around that. So we'll wait just a little bit. As before, we can click on each gas to look at the trend over time. So we'll just give it a 4 or 5 minutes for things to level out, and then we'll go ahead and do the span. Alright, so it looks like the methane has stabilized quite nicely. There's no movement or change over time, and the mean value we see here has stabilized. So when we're ready to calibrate, again we go to settings page, go to advanced, and for calibrating the span, we type in the value of the tank in parts per billion. So this tank has 1.99 ppm, which will translate to 1990 parts per billion. And once you type in that, this value, this button gets activated. We'll go ahead and click span. It will ask, are you sure you want to span CH4 for this instrument? Yes, I'm sure. And that's it for span. There's no wait. It quickly just takes the readings and calculates the multiplier, and that multiplier is now going to be applied for both CO2, water, and methane. Because we were already right at the same point, there's not a significant step change or a noticeable step change. There is a small change, but nothing noticeable. And the CO2 and water readings are also adjusted by the same amount. And that's how we do zero and span calibration on the LI-7810. If you have questions about the calibration, or if you have general questions about this instrument or any of our LI-COR instrumentation, you can go to our website. We have technical documents, more videos, and instruction manuals that you can refer to. You can always contact us as well, or your local LI-COR distributor.